Hi, I'm Dr. Alston Mesquita from Queen Mary, the Department of Physics and Astronomy in Queen Mary, University of London. And I'm here now to talk to one of our doctoral candidates, Rony Letona, who is now in his second year and he's working on a project on disorder in molecular crystals with a private firm, one of the unique candidates we've got here. Who's the only one working in a private company. And well, on to you, Rony. You're working on disorder, and I see you've got chocolate there. Could you tell us what you're working on and why it's associated with chocolate?
Thank you, Alston. As you can see, I have some chocolate here because it is one of the things that I've been doing research around, in the sense that chocolate is one of the molecular crystals that we see every day. We interact with these crystals, but we don't actually know what they are until we kind of study them. And chocolate is like the perfect example, especially because when you think about chocolate, you always think about this feeling that you get when you have this nice chocolate. But have you ever had this bad moment in life where you left the chocolate to melt somewhere?
And then it becomes all... It changes texture, doesn't it?
Exactly, and it gets all these white freckles on it. Yeah, well, turns out that the chocolate that you had before and the chocolate that you have afterwards are not the same thing. We call them different polymorphs, different because they have different shapes inside of them. The crystals are different.
So is it the same? It's the same molecules, but polymorphs, the molecules are packed differently, isn't that correct?
Yes, exactly. They're rearranged in a different way. And the funny thing about it is that their properties also change, because as I imagine you have seen, this chocolate melts in your mouth, but once it has undergone melting,
it becomes harder.
Yes, indeed.
Exactly. Yes.
So the same, we have discovered that the same happens with medications, and that it may be a problem, because if you take a pill, you want to somehow know that the pill will do its effect. Mm-hmm. But what happens if people test it and the components are there, the molecules are there, but it doesn't do the same effect because it's a different crystal?
So what has disorder to do with polymorphism in molecular crystals?
I'm glad that you asked, because that's exactly my research topic. As you can imagine, these polymorphs that I mentioned, they're specific packings of the crystal. But disorder is a more subtle thing. So it's when one molecule, it doesn't completely change its shape, it just changes slightly in some particular way, that the whole crystal changes its property. And in the case of medications, it turns out that now it's not soluble, or now it doesn't have the same effect. And we need to predict this.
So disorder can change the properties of the molecular crystal, and then its effect on the body, its effect on how the drug is released in our bloodstream. Is that the kind of phenomenon?
Indeed, it may come to that. There have been some cases where medications have stopped working because you have a different polymorph. In the case of disorder, this is a little bit more of a nuance, but some medications have already exhibited some disorder in their crystal structure, and before any accident happens, we want to make sure that they work as they should.
Now, how exactly does disorder fit into the subject of your research? How do you start to model disorder? And what would you regard as a successful PhD in the scientific sense?
Oh, that's an interesting question.
Aha.
So, modeling disorder is not something as easy as I thought. At the beginning, we tried to categorize what kinds of disorder we may find in crystals, and it turns out that even though there's a small amount of them, like the different types of disorder, what they can do inside the crystal is that they can rearrange in so many particular ways that you get all these possible configurations of the crystal, where the molecules get disorder in several different rearrangements. And it turns out that when these rearrangements when you want to model these rearrangements, you kind of get into a problem. You get so many possible configurations that the last time that I checked, we would have to predict more configurations that there are atoms in the known universe.
That is a lot.
That is too much. Nevertheless, to finish with your question, what does this have to do with my PhD project? Well, a successful PhD project would mean that we somehow managed to overcome that barrier, and we somehow managed to find a representation of the important configurations, at least, so that we can guarantee that these medications work.
Now, you talked about the PhD project and what would be a successful project, but can you tell us a little bit about what it means every day? I mean, you're not in the lab, you are in a computer lab. So when you talk about modeling, what are you doing exactly?
So, I will try to walk you through a regular day so that you get a better idea. As you were saying, yes, we don't work in a regular lab, and I say we because I'm working in a company, as you remember. The thing is, while working in a company, I expected, I don't know, to see more computers, to see everyone having formulas on boards and stuff like that. It turns out that you go there and it seems like a very regular office. The formulas are still there on the board, but it seems like a regular office because we spend a lot of time writing code. We spend a lot of time testing different ideas. Most people think that we're only looking at molecules into the screens, but that's like when we get a successful result, we may see a molecule. The rest of the time, we're just seeing code and numbers, and we're trying to test different ways to produce those numbers.
And I guess your clients here are pharmaceutical firms, but that's under some, well, it's a trade secret, right, as to who exactly is using?
Indeed, that is something I cannot speak about, but yes, I can tell you that there are several pharmaceutical companies interested in these technologies because they want to somehow guarantee that their products will always work.
So that puts you in a unique position, doesn't it? You are in a private firm which is doing research, but the research is under probably an embargo. You can't talk about it. And yet, you're juggling science, which is open, and you're juggling concepts, intellectual property, which is private. How do you find yourself dealing with that? Because it really puts you in this very unique position, which the other doctoral candidates in PHYMOL are not in.
It has been a challenge, I have to admit, but at least I have a very clear distinction between the stuff that I can talk about, which is everything related to my research. That I can talk about. Actually, I have given several presentations about that, which have led me to different countries in the European Union. That has been nice. But on the opposite side, whenever I'm inside the company is the only time that I can talk freely about everything that I'm doing. So there is this double life that you have to live. Nevertheless, you get used to it after a while. I mean, the stuff that you do inside the company, it's important. It really has an impact, an immediate impact, because it's also applied in the pharmaceutical industry.
Yeah.
But at the same time, I know that I'm contributing a little bit, and that satisfies me. And that keeps me happy for the rest of the day outside the company.
So it's the immediate applications you're aware of, and the science, and the fact that you're making this contribution to things which have an impact now. That's a good position to be in.
Indeed.
Now let's switch to something a little more social. PHYMOL is an international project. You have come in from pretty far away, from Guatemala. Now, how did you find this? How do you find this movement to another country? You're moving around. You're not just in Germany, but you're moving around the Europe. Do you like it?
I do. I really do. You see, in my country, I didn't have the chance to study this or to apply any of the knowledge that I have acquired. At the beginning, I came not directly to Germany, but I did a master's degree in Spain. And you would expect that coming from Guatemala, a Spanish-speaking country,
Yeah.
Spain wouldn't be such a shock. But in fact, you do feel a cultural impact. And then moving to Germany was another level. Nevertheless, what I can tell you is that I have found more caring people than I expected. There's this misconception that the German people have a very particular way of living and they have a very particular personality, but I have found very sweet people who have helped me and have made my journey a lot easier than I originally expected.
That's always good to know. Now,
Indeed.
but we also have a kind of PHYMOL community. Can you tell us how you have felt what's it been like to be in this network of people who have come from so many places?
That has been enriching. That's the first word that comes to my mind, because I have learned so much about different cultures and about different ways of thinking. I don't know how to explain this. Even though our common language is chemistry and math and programming to a certain extent, the way we see life, the way we enjoy things, especially when we're outside the conferences or the office or computer lab, that is so enriching. Yes, that's the correct word.
That's always good to know. And would you recommend PHYMOL to other people?
Of course I would. Or any doctoral network of this kind. It is not only an enriching experience from the point of view of the science or the people. You learn so much more about yourself and about how you live and how other people live and the impact that you have on other people's lives. It's incredible.
Thank you, Rony. It's a pleasure to have you in the network, and I hope everything goes well in the rest of your PhD.
Thank you very much, Alston. It has been my pleasure as well.
Thank you, Rony, and thank you all for your attention, and see you at the next interview with a PHYMOL candidate.